Shall we start?
Yes, sir.
Okay, fine. Yesterday, seen the pressure design or called. So, design pressure is the maximum pressure that the system or that can be exposed to and set the system relief wall at the same pressure. And this pressure should be below maximum allowable working pressure, and based on company standards can vary from 10 to 25% above the maximum operating pressure of the system. Is it clear to everyone? What is design pressure?
Yes, sir.
Okay, fine. Now here, see the numerical examples. A 12-inch nominal bore pipe has an internal maximum operating pressure 500 psig. The pressure square inch case is can convert into 35 kg per centimeter, and temperature 675 Fahrenheit. The material of construction of the pipe is seamless carbon steel. 2. ASTM A106GR, that is group B. The recommended corrosion allowance is, here CA is given, 1 over 8 inch, that is 3 millimeters. Calculate the thickness of pipe as per ASME B 31.3 and select the proper schedule. Means we have to select the proper wall thickness. Okay, in solution, see, first we have to find out that is TM parameter. What is TM? So here consider minimum thickness. Okay, first task is to find out the minimum thickness. So here thickness equals to P into D, or 2 into in bracket SE plus PY, bracket close, plus C. So all terms are defined in earlier lectures. Now again we'll see what is P. P is nothing but internal design gauge pressure. D is outside diameter of pipe. S is allowable stress. We can pick this stress value from appendix A1 for ASME B 31.3. You can see the handbook, Mohinder and Nayer's, already uploaded in Google Classrooms in section classwork. And E is joint quality factor. Again, we have to select joint quality factors from tables given in ASME B 31.3. And coefficient from 304.11 clause. So from this clause, we can select the coefficient. And then so we add C1 and C2. Means C1 is corrosion allowance. That is 1.6 millimeter general for carbon steel, CS. And if you are consider stainless steel, there is no corrosion allowance. And C2 is depth of thread. So we find out all the parameters, then substitute all values, you can find out the calculate film thickness of pipe as per ASME B31.3 and select the proper schedules means wall thickness. Can abbreviate schedule SCH. So in solution, so TM here P is 10% higher than MWP. MWP stands for the maximum working pressures, or we call maximum allowable pressure. So designer is the maximum pressure that the system that can be exposed to, and set the system relief wall at the same pressure. This should be below maximum allowable working pressure and based on company standards and can vary from 10 to 25% above the maximum operating pressure of the system. So here we are considered that is 10% higher than maximum working pressure, or it is also called as maximum operating pressure of the systems. And here diameter is given, outside diameter, that is D is outside diameter of the pipe. So based on this nominal bore pipe size, that is 12 inch, and here maximum operating pressure is 500 psig and temperature is given 675 centigrades. So here you consider the design pressure that is higher than maximum working pressures or maximum allowable working pressure is higher than this, we are considered 10%, but here we can vary between 10 to 25%. Now here considered higher than 10%, then you will get 550 psi. And here outside diameter, so here outside diameter of 12 inch nominal bore pipes. So for ASME P 31.3, if it is outside diameter 12 inch and then diameter this pipe is 12.75 inch. For ASME B 31.3 standards. And other parameter is design temperatures. So here given is 675 temperatures, say in centigrades. So here we are considered the operating or maximum allowable working pressure is 10% higher than maximum working pressure. So therefore we have to consider addition of 25 centigrades for 10%. If you are considered 20% higher than the maximum working pressures, then here in design temperature, we have to consider 50 Fahrenheit. So as per ASME B31.3, and design temperature is 700 Fahrenheit. And here S is allowable stress from appendix A1. Design data book is given under ASME B31.3. Therefore, we are considered level stress that is 16,500 pressure square inch, that is PSI. So here we are referred ASME B31.3 appendix A and table A1. And another is joint quality factor. We are considered 1 as per ASME B31.3 appendix A and table A-1B. From this table, we pick the value of joint quality factor, that is 1. Now next is coefficient. Y is coefficient 0.4 as per ASME B 31.3 and table 304.1.1. So here coefficient is 0.4 from these tables. And here C, what is C? C is, that is corrosion allowance plus depth of thread C1 plus C2, called corrosion allowance plus depth of thread. So here considered, that is recommended corrosion allowance is 1/8 inch, and here material is used for this pipe carbon steel, seamless carbon steel, to spur AS, American Society of Testing of Materials, under A106 Group B, and we are considered here, that is 0.125, this specified. Okay, now then we have to substitute all values to find out the minimum thickness. So based on this relation, can find out the minimum thickness. Here P is known, D is known, S is known, E is known, that is joint quality factors. A is allowable stress, and P is a design pressure, Y is coefficient, and C is nothing but it's the addition of corrosion allowance plus, that is depth of thread. So here consider 0.125. Substitute, put all values. P is 550 into D is 12.75 inch, and 2 in bracket here 16,500, that is allowable stress, into another parameter is E. E is nothing but joint quality factors plus another is design pressure. P stands for the design pressure, that is 550 psi, and into coefficients, that is 0.4, bracket close, plus here C is 0.125 inch. The simplification this relation, the so the calculation and verify these values. Here becomes, after simplification this relation, so 0.2097 inch plus 0.125. Addition of these two quantities, here we'll get the minimum thickness, that is 0.335 inch. Here we have to consider the milli tolerance of 12.5%, so that the nominal thickness for minimum thickness of 0.0335 inch per calculation. So here we have to consider the minimum 3 inch. This is the minimum thickness after considering the milli tolerance of 12.5%. The minimum film thickness is 0.83 inch. In industrial practice, we can specify the wall thickness, or we have to select the proper schedule. It means we have to consider SCH 40. This minimum thickness, this pipe comes under schedule of 40 pipe, which has nominal wall thickness. Consider this value, and as per schedule 40, so here we'll get 0.406, that is nominal wall thickness, and minimum thickness is 0.355. we are considered 0.406 into 0.875. So here we can select the proper schedule is schedule 40, and thickness of the pipe as per ASME 31.3 is 0.383, and wall thickness, that is nominal wall thickness, of 0.406. The calculation to find the thickness of pipe as per ASME 31.3 and selection of proper schedules, that is SCH 40. Now see the thickness of the paint. To find out the thickness of the paints, so we can use different kind of bends. Bends are actually MSSSP dash SP. These are the manufacturer standards. These are not designed as per ASME standards, but as per the requirement of industry, we can manufacture the different kind of bends, and we are design bends as per the requirement of vendors as well as industries. But we have to refer ASME B 31.3 minimum thickness, that is TM of bend. After bending in finished form, we have to consider inside and outside thickness for this bend. So with the help of this standard ASME B 31.3, we can establish minimum thickness of bend. So here, with the help of this relation, that is T equals to P into D, here 2 into in bracket E plus E divided S into E divided by I plus P into Y, bracket close. So here we are considered additional one term, that is I. So I is yes, we mid span. Therefore, to consider I equals to 1. If you consider the inside bend radius, this is called extra dose, and outside radius of the bend we call the extra dose. And how to calculate the inside radius of bends? So here, with the help of this relation, can calculate I equals to 4 into R upon D. That is, R is Ri. Here we have to consider Ri. That is the internal radius of the bend. And so this is nothing but the outside diameter of the bore minus 1 divided by 4 into R1 divided by D minus 2. With the help of this relation, so we can find out the bend center line radius. And big steps means outside bend radius. There are two type of radius of bends. One is inside, another is outside. See here, from this direction, if we extend this arrow to here, so we will get the extra dose, and another one is internal, one is intra dose. So based on this relation, means I equal to 4 in bracket Ri over D plus 1 for outside bend radius divided by 4 into Ri, that is inner bend radius, or D, bracket close. The side wall, the bend center line radius I equals to sorry, 1. And here we have to consider the thickness at the midspan. So it's denoted by comma. So we have to consider gamma at the midspan, that is gamma divided by 2. So based on that, we can find out the thickness of paint. Okay. Now next, pipe fittings. In earlier lecture, we have seen the 3D sketches of some pipe fittings. Now some pipe fittings are classified based on end connections. In earlier lecture, we are considered some end connections. Now again, we will revise end connection. First, we call these socket welds. Next one is a screw weld. Next one is a butt weld, flange, spigot or sockets, and buttress. So here, consider the butt weld. So it's broadly considered that is a ends in stub ends. One is a long span, another is a short spans. Front pipe fittings ends. That is, first one is 45-degree elbows and another is 90-degree elbows. Here we call the short radius or long radius elbow. That is SL or that is RL. Can consider short radius or long radius elbow, or we can read 45-degree elbows or 90-degree elbows. Now next 180-degree returns. That is short radius and long radius. And third is T's. Here equal T's and reducing T's, and cross. There is two kinds of cross. One is equal cross, another is reducing cross. Some are discussed, another is caps. With the help of this cap, so we can close the end of the pipe or a run in the process industries. So reducers, here two types of reducers. One is a concentric reducers and next one is eccentric reducers. And next fitting is coupling. So here we'll see the half couplings, full couplings, and reducing couplings. And third pipe fitting is wedge and nipple. So here is first concentric wedge nipple and next is eccentric. So they are quite similar to reducers like concentric reducers and eccentric reducers. And next component, that is a unions. And next one is spatial fittings. The spatial fittings, see the weldolets, socolets, throdolet, elbolet, sweepolet, nipolet, and laterolets. We'll see one by one all kind of fittings, their line diagrams, and where we are using all kinds of pipe fittings. Now we'll see the dimensional standards. Let's see the all kinds of fittings, then dimensional standard is required. How, from which standards we have to see the flanges and flange fittings. What kind of materials are used for particular flange? If you consider ASME 16.1, so in this standard, so we can see cast iron pipe flange and flange fittings. And next is ASME 16.3. So here can see the malleable iron threaded fittings. Only that kind of fittings and materials we can see in ASME B 16.3. Now next standard for gray iron threaded fitting. So here material is a gray GI, that is a gray ions. So as per ASME B 16.4, we can see the threaded fittings for gray iron ions, that is Gi. And if you consider CMI threaded fittings means malleable ion fittings, threaded fittings, then we have to refer ASME B16.3 and pi flanges and flange fittings. So as per ASME B 16.5. So here we'll see only flanges and flange fittings. Here there is no concern with any kind of materials. Now next one is ASMEP 16.9. So factory made rod steel butt welding. So these are the manufacturer standards. Therefore here to consider the factory made rod steel butt weldings. Now next is ASME B 16.1. So here forged fittings, socket weldings and threaded. So that kind of weldings can use only ASME B 16.11. And next standard rod steel butt welding, short radius elbow and returns. You can refer ASME B 16.28 for dimensional standards. So another standards for the ASME 16.42 for ductile iron pipe flanges and flange fittings. Now next is butt welding induction bands for transportation and distribution system. So here we can refer ASME 16.49. And next standard, that is Bureau standards, that is a BS. So here but weld fittings for 1640 and PS 3799 for socket weld and screw end fittings, and glass pipelines and fittings. For this we can refer BS 2598. Now next is IS standards, that is 1239 part 2 for MS fittings, here mild steels. Okay, and next is CI fittings, that is cast iron fittings for IS 1538, and stainless steel pipe fittings to refer MSSP for 3. That is a manufacturer standardization special practice. So in this practice we have to refer that kind of dimensional standards. Now see the classifications, the paints. So in this classification based on end connections, first is a socket weld, screw end fittings. That kind of fittings we are discussed in earlier lectures. Now these fittings, here four pressure classes are given. First one is 2000 class, 3000 hash class, and 6000 class, and 9000 class. This is the pressure classes are available as per ASME 31.3. So we'll see the use of all classes. If to consider the based on classification of these fittings. So here 2000 class, 3000 class, 6000 class, 9000 class. These designation represent the maximum cold non-shock working pressure of the fitting in pounds per square inch. What this designation represents the maximum cold non-shock working pressure of the fitting in pound per square inch, that is PSI. Now first class is 2000 class. First rating in this class means 2000 class is applicable only to screwed fittings and is covered only in ASME B 16.11 and BS3799. The corresponding pipe thickness for this class is schedule 80 or XS. So here pipe thickness can find out based upon the schedule 80 or XS. 2000 class is applicable only to screw fitting and is covered only in ASME B 16.11, and pipe thickness for this class is schedule 80 or XS. Now here first class is for next class 3000 class. In 3000 class, this class is applicable to both screw and socket weld fitting. See the difference. Earlier class means 2000 class is applicable only to screw fittings. Now 3000 class is applicable to both screw and socket weld fittings, and corresponding pipe thickness for this class is schedule 80 or X for socket weld connection and schedule 160 for screw end connection. So here pipe thickness class or XS for socket weld. This class is applicable to both screw and socket weld fittings. And schedule 160 for screw end connection. So here to consider the schedule 160 for screw end connections. This kind of connections we have to consider. Now next is 6000 class. Now next class, there is a pressure class 6000. This class is also applicable both screw and socket weld fittings. An earlier class, that is 3000 class, is applicable both class screw as well as socket weld fittings. And earlier class, that is 2000 class, is applicable only screw fittings. See the difference. 2000, 3000 and 6000 pressure class. Now socket weld fitting under this class are normally used with schedule 160 pipes. Here pipe thickness for this class should consider the socket weld schedule 160 and screw fitting with double XS pipes. So based on that, can consider the corresponding pipe thickness for this class. Socket weld fitting for this class now is schedule 160 and screw fitting with double XS pipes. So kind of pipe thickness for this class. Now next pressure class is 9000 class. Here 9000 class. So this class is applicable to socket weld fittings, which are normally used with double XS pipes. Means here pipe thickness to consider double XS means double standards, and this class means 9000 class is applicable only to socket weld fittings. The screw end fittings can be with parallel threads or with taper threads. Taper threads are prepared for the fittings. These could be normal pipe threads are covered in American standards or covered in British standards or to relevant Indian standard specification. So here consider different standards, that is American standards, British standards, or some relevant standards are available in Indian standard specifications. The dimensional standards, that is ASME B 16.11 slash British standard, that is 3799, cover the sizes up to 4 inch, means 100 millimeters nominal bore of pipes. The socket weld or screw fittings are manufactured by forging. The material of construction used for the same considered for screw or socket weld fittings. So here we have to consider the material standards for different analysis. So that is to consider the forged carbon steels as per ASTM A105, ASTM A181, forged carbon steel for general purpose. Another material is forged alloy steel and stainless steel as per ASTM A182. And next material for socket weld and screw fittings, that is wrought carbon steel and alloy steel pipe fittings for moderate and elevated temperature. So wrought carbon steel and alloy steels pipes fittings used in moderate and elevated temperature. Next material, that is a forged alloy steels. Only forged alloy steels used for low temperature service as per ASTM A350. So that kind of materials are used for different kind of pipe fittings. So here can see the different types of fittings. There is short radius elbow. So here R equals to radius of the elbow equals to 1 into diameter of the pipe. So we can identify this is a short radius elbow. Next is long radius elbow. So equals to 1.5D. See the difference to calculate radius for short and long radius elbows. Short equals to 1 into D, the diameter of the pipe, and R equals to 1.5. That is the outside diameter of the pipe. It's called the long radius elbows. And next is there is an elbow in 45 degrees, and another is elbow 90 degrees. There are various types of fittings used to complete the piping systems. These are used to change direction, change diameters. See, this is the purpose of using different kind of fittings in piping systems to use to change the direction, change the diameters, and help of elbows. Elbows are used to make 90 degrees or 45 degrees changes in the direction of run pipes. That is a pipeline. So here in piping industries, so we always use a run pipe, sub pipeline. Therefore, elbows are used to make 90 degree or 45 degree in the direction of run pipes. So there are two types of 90 degrees. First one is a butt welding elbows available for use in industry. Nowadays, they are used the butt welding elbows, and these are the long and short radius elbows. The long radius elbows have a bend radius of 1.5 D. Here, D is the nominal size, or we call the outside diameter of the pipes, whereas the short radius elbow have a bend radius of 1D. Again, here where D is the nominal size or outside diameter of the pipe, and the 45 degree elbows are of 1.5 into D radius. Any bend with more than 1.5 D. If any bend, if you consider any bend, so more than 1.5 D bending radius has to be specially made as per requirements. Means as per requirement of chemical industries, petrochemical industries, or hydrocarbon facilities, they are demanded as per their requirement to design more than 1.5 D. That kind of fittings we call the special fittings. For large diameter piping, bends are fabricated by profile cutting of pipes and are called which bends miter bends. That is 45 degrees and another is 90 degrees. For large diameter piping, bends are fabricated by profile cutting of pipes and are called miter bends. Miter bends with two pieces, three pieces, or four pieces. Construction can be made. See here, to consider the different pieces 1, 2, 3, 4, 5. And in 45 degrees, we have to consider 1, 2, 3, only three pieces. So, either bends with two pieces, three pieces, or four pieces construction can be made. These are normally not used in critical services. We never use that kind of critical miter bends. So, why we are not using? So, it will not prevent the leakage in piping systems. Therefore, to consider different kinds of special fittings. These are normally not used in critical services. 12.5 degree elbows are also available in cast iron construction. So here I've seen only two miter bends. First one is a 45 degree and second one is a 90 degree. But another kind of miter bend is available in the market as per the requirement of piping industry, that is 22.5 degrees. It's available in cast iron construction. So here you can use CI materials, and with the help of these materials you can manufacture the miter bend having 22.5 degrees. And what kind of materials available for flange and fitting materials? So as per ASTM A216 carbon steel castings and ASTM A351 stainless steel castings. So these fittings are covered under ASME B16.5 and British standard, that is 1650 for carbon and alloy steel pipings, and ASME B16.1 for CI fittings. So with the help of this standard, so we can consider flange and fitting materials and use in piping industries. Now, next is flange in the radius end fittings. Fittings with both ends or flange are used where welding is not possible. Then we can use the flange end fittings. The both ends flange are used where welding is not possible or not permitted in piping industries. Normally, these are made by castings. Maybe you heard the terminology castings in manufacturing engineering. With the help of castings, we can make the classification of these fittings based on pressure temperature ratings. So earlier we have seen the pressure ratings. This is 2000 class, 3000 class, 6000 class, 9000 class. These are the pressure ratings. Now here we see the classification of this fitting based on the pressure temperature rating as the flange fittings are fabricated from standard butt weld or socket welded fittings or butt welds not covered under the standards. These material specifications the same that for the castings. To consider kind of same materials. And now next fitting component, that is returns, cross, reducers, long radius returns. Returns change the direction through 180 degrees. See here 180 degree. The help of return change the direction through 180 degree. This is mainly used in heating coils, heat exchanger, returns with 1.5 into D radius R equals to 1.5 into D and R equals to 1 into D are available. In returns, there are two types of returns are available. One is a short, another is long. Here we have to consider radius equal to 1 into D, another is 1.5 into D, like a long radius elbow and short radius elbow. But here the direction through 180 degrees for short returns or long returns. Now next parameter is a cross, or next fitting is cross. In cross, it's a fitting very rarely used in piping industries or in piping systems. There are two types of crosses. One is a straight cross and reducings. To reduce the inventories, it is preferred to use P's except where space is a restriction, as in marine pipings. So in marine pipings, can use if it is there is a space limitations, as in marine pipings. It is referred to use these sets where space is restricted, in marine piping. So in cross fittings we can use. Now next is tees. So there tees we can consider, that is reducers, concentric reducer and eccentric reducers. Here there are two types of reducers available in piping industries. First one is concentric reducer and eccentric reducers, where the center lines, see the center lines are both reducers, concentric and eccentric. When the center lines of the larger pipe and smaller pipe to be maintained same, the first case is called as concentric reducers. When one of the outside surface, the surface of the pipelines are to be maintained same, then the eccentric reducers are required. See, the eccentric reducers are required. There are no eccentric reducers in socket weld fittings. In socket weld fittings, eccentric reducer fittings are not available, and swage nipples are used. See here, you can see the some swage nipples. So there is a size restrictions are used for such services. Means we have to maintain the center lines, the pipes. So here we can use the swage nipples are used for such services. And the size restriction for the surface as per T fittings, two reducers. In T fittings, these are used for branching off for low pressure services. See the T. Here can connect three pipes with the help of butt weld connections. These are used for branching off for low pressure services. Branching off is done by direct welding of branch pipe. See here you can weld another pipe, and here one more pipe you can connect, and third pipe in vertical directions. So we can connect with the help of butt welds. So it's done by direct welding of branch pipe. To run pipe, instead of using a standard tees, here instead of using standard tee, we can use normal tees and use for branching. In certain cases, reinforcing pads are used for structural stabilities. Why? We use the reinforcing pads for structural stability of such connections. So here if you connect all three branches, means here it leads instability. For this purpose, we have to use reinforcing pads used for structural stability for such connections. Design code gives the calculation by which the requirement of reinforcement pad can be established and provided for branch connection as per ASME 31.3 Appendix H. The help of these standards, so we can calculate the requirement of reinforcement pad and can be established. The manufacturing restriction do not allow reducing tees of all size combinations. To arrive at available sizes of reducing tees in the standards, use thumb rule of dividing major diameter by 2. With the help of this thumb rule, dividing the major diameter by 2 and consider the next lower size. For an instance, the maximum size of reducing T available for 4-inch nominal bore size is 4-inch by 1 into half inch. The next lower size of 4 by 2 is 2 inch. So that kind of thumb rule to applicable, dividing the major diameter by 2 and considering the neck size. So this is all about the few piping fittings. And in next class, we'll see the different kind of stub ends and couplings. Okay. Any doubts, any questions till now? Yes. Yes, Srikant.
No, sir, no doubt.
Okay, anyone?
Hello, sir.
Yes. Yes, Pratik.
Yes, sir. How we selected the stresses values in the numerical?
Okay, in numerical, based on C, here ASME B31.3. Okay, here appendix A and table is A-1. And here pressure, see the pressure rating, that is 550 pressure square inch in gauge, so that is 550. Based on that, we can select the allowable stress, that is 60,500 pressures per square inch.
Yes, sir. But at 700-degree Fahrenheit, the S was different in the appendix. Means in this table.
See, in allowable stress, there is a variation depending upon here design pressure. In earlier, we have to define the allowable piping design pressure. In piping design pressure, we have to consider the some variations, that is 10% to 25%. Plus variations we have to consider in design pressure. So based on that, this allowable stress can be varied. So the maximum pressure that the system that can be exposed to and the sets the system really fall at the same pressure, and this should be below maximum allowable working pressure, and based on company standards can vary 10 to 25% above the maximum operating pressure of the system. So based on that, these allowable stresses will be varied. Okay.
Yes, sir.
So here it's a little bit tricky. So here we have to consider standards and some company standards. And based on that, we have to calculate the design pressure, and we can vary between 10 to 25%. Must be above the maximum operating pressure in the system. That is the reason sometimes these pressures, that is allowable stress, will be vary as per ASME B31.3. Or
Sir,
any,
but which value to be considered means in between 10% to 25%?
so you can start from lower to higher, and even for the allowable stress, we can consider lower to higher, but always focused on minimum values. So if you increase the values, then ultimately leaves the material costs. In piping industry, we have to consider the monetary factor. This is very important. Designing or any piping fitting components, we have to consider the minimum dimensional parameters.
Yes, sir. Okay, thank you.
Okay, we are studying for a low temperature and pressure application services. We are not considering high temperature and high pressure services. If it is high pressure and high temperature, then definitely we consider for the 25% for pressure as well as temperature. Is it okay?
Yes, sir.
Okay, fine. Next, anyone? Any question? Rahul? Aditya? Prajakta?
No, sir.
Yes, sir.
Okay, fine. Then we'll close this session here and we'll meet in next session.
Thank you, sir.
Thank you, sir.
Okay.